When we are talking about linear motion, we also need to understand the three equations of motion. The first equation of motion: a body in motion remains in motion, or a body at rest remains at rest until acted upon by a force. So this explains why when you are in a vehicle and the vehicle is moving, immediately it stops, you are going to be pushed in front. And when the vehicle is not moving, if someone just uh, steps on the accelerator, starts moving, you're going to be pushed behind. That is because your body wants to remain in the state in which it is. So if there was no force to be able to push you behind, for example, if you are moving, imagine you are moving and there's no force that is acting in the opposite direction to stop you. According to the first law of motion, it explains that you continue moving and moving and moving and moving. That is why, if you we can also apply this when you talk of planets which are moving. They are always moving around and around and around. But well, this is just an example that I'm giving. As long as there is no force in the opposite direction, they'll continue moving and moving. Now, these are not moving in a straight line. Here we are talking about motion in a straight line. Okay. So when a body is in a state of motion, whether it is moving or not moving, it will continue being in that state unless you push it. There's no way. If you put a box on a table, even if it is 50 years later, 100, 1,000 years later, you still find it on that table. If there's no one to push it, or if there's no force acting on that box, it shall never move by itself. There's no magic. Now, the first law of motion is also called the law of inertia. Inertia is simply the tendency of an object to resist change in motion. So if an object is moving, it will always want to avoid stopping to move. And when an object is not moving, it will always want to avoid starting to move. So the tendency of a body to resist change in motion or in the state of motion is what we call inertia. Now, the measure of inertia, the measure of a tendency of a body to resist change in motion is called mass. Just pay attention. Multiple choice questions in physics are there. So mass is the measure of inertia. All right. Now, second law of motion. Second law of motion tells us force equals mass times acceleration. This is just a very simple form. So it tells us that acceleration of an object is direct proportion to its mass and inversely proportion to direct proportion to the force applied and inversely proportion to its mass. This tells you that when you've got two objects, you have got A and B, these are vehicles. You've applied the same force to push them. When you apply the same force, this one, which is smaller, is going to be able to move much faster than this one, which is bigger. What is the reason? That is because you can see that mass and acceleration are inverse proportion. So if mass is big, then acceleration is going to be small. If mass is small, acceleration is going to be big. They are inverse proportion. Okay. I'm going to talk about it again. Let's talk about third law of motion. For every action, there is an equal and oppositely directed reaction. So any action, anything, others say whatsoever goes up must come down. So if you hit a wall, you can ask, why is it that when if I punch a wall, I'm going to feel hurt? The wall doesn't do anything to you. Well, the thing is this: when you hit a wall with a certain force F, the same force that you have applied on the wall is going to apply that same force on you, but it is going to be in the opposite direction. That's why we're going to put a negative there. So any force that you apply is going to be in that same force that you are going to receive, but in the opposite direction. So you can think of this: when you get a ball in your hands, you throw it. your hand is going to be pushed behind. With the same force that you push the ball, your hand is going to be pushed behind. But what will determine how fast your hand moves is the mass. So you can think of it, when you get a very heavy thing, for example, uh, let's say a big stone or a block, you want to throw it. When you throw it, it will more push you behind. But when you get a very small stone, you throw it, you'll not even feel that much impact force pushing you behind. That is because the acceleration at which you are going to be pushed going behind depends also on the mass of what you are throwing. So we need to know these laws. Third law of motion applies on many things, and we're going to be talking about applications of laws of motion in the next tutorial that we're going to have. So we need to know this well. We are going to talk about why is it that objects are not moving. Why is it that, according to, if you put a box down, it will not be moving? So whenever you put a box down like this and it is not moving, this means that all the forces on this object are balanced. You need to know that any object that is on a surface has got a normal force. A force that makes 90 degrees to a surface is called the normal force. And then any object has got a weight force. So these forces, the weight force and the normal force, they are balanced. That is why this box cannot go up or down. And then if you are, imagine you are applying a force that is called applied force, like you are trying to push this box but it's not moving. That means that there is a force of friction in this direction that is preventing the box from moving, and these two forces are equal. That's why the box is not moving. I'm talking of the normal force. So if I've got a surface like this, imagine maybe an incline, I put a box on an incline like that, then the normal force is going to be like this. Normal force will always make 90 degrees to that surface. If the surface is like this and then I attach an object there, then the normal force is going to go like this. If a surface is like this and then I put an object down like that, then the normal force is going to be down. So in this case, the normal force is going to be the same as the weight force. So normal force always makes 90 degrees to an object, and it will always go like more like outside an object. Hope that makes sense. Please, let's know these laws. Very soon we'll be understanding how to apply them, these laws of motion. So these are some of the things that you should be able to understand when you're talking about linear motion. You need to know the three equations of motion. V is equal to u plus at, and then we have got S is equal to ut plus half at squared, and then we have got v squared is equal to u squared plus 2as. I'm going to put a fourth one which you not use that much. S is equal to v plus u divided by 2 times t. So these equations we need to know. So if you are talking about linear motion, these are the ones you are going to use. But if your motion has changed, now you see motion going up, then it becomes, the first one will become v is equal to u plus a, acceleration is now becoming g, because you're talking about something that is subjected to gravity. And then s is, which is distance, when you're going up, that is going to be called height. So height is going to be ut plus half, where there's acceleration, that will be g t squared. And then this one will be v squared is equal to u squared plus 2a. Now the a is going to become g, the s is going to become h, and then the last one, this is going to be h is equal to final velocity plus initial velocity divided by 2 multiplied by the time. So this is what the equations become.